Hello students, the experiment that we are going to perform today is to find the springs constant of a helical spring by plotting a graph between load and extension. So let's discuss what's spring constant. Spring constant is defined as the restoring force per unit extension in the spring. Springs constant is also termed as the force constant of the spring. This experiment is also known as Hooke's law experiment. Hooke's law states that within the limits of elasticity, the strain produced is directly proportional to the stress applied. So now let's discuss the apparatus to be used for this experiment. First of all, we need a rigid support. This is a rigid support. This is a boss head. This is a helical spring. This is the weight hanger. And these are the slotted weights. In addition to this, we also have a meter scale. This is a meter scale on which we have to note down the readings. Now let's discuss what is the helical spring. What is a helical spring now? This is a helical spring. A helical spring is a wire coiled in a form of a helix, whose function is to distort when load is applied on it and to return back to its original position when the load is removed. Now let's start the experiment. First of all, take a helical spring and hang it onto the rigid support. On the another side of this helical spring, we hang a weight hanger. Then we note down the reading at the meter scale. I have adjusted it such that the reading with the weight hanger shows 0. Now, we are going to put on a slotted weight into the weight hanger. The weights we are using, the slotted weights we are using are 20 grams each. When I put the weight in this weight hanger, the spring extends and the pointer moves downwards. Let it come to rest. And then once it comes to rest, we have to note down the reading. Let's say it's around 3.2 or 3.3 centimeters. Then again we are going to add another slotted weight. The spring will extend further and the pointer will move downwards further. Again we are going to put on weights, like we are again going to put on a 20 grams weight. The spring will extend further and we have to note down the readings on the meter scale. Once we have taken 5-6 readings like this, after that we have to start removing the weights one by one and we have to note down the readings again. Like this. Once we have removed all the weights, we have to note down the readings and take the mean of loading as well as unloading of the weights. We note down the readings on the observation table like this. First is serial number, then is the mass in grams, like it would be 20 grams, then second would be 40, then 60, then 80, then 100, then 120 and then 140. Then we have to convert it into kg. After that we have to calculate the load. Load is mg. M is the mass in kg and g we have to take as 9.8. So multiplying both we would get the load in newtons. These are the pointer readings that we noted down while loading as well as unloading. Then we have to take the mean of these for all the readings. This is the extension. Like first it was 3 point something, then it was 6 point something, and we noted down all the readings. Then we have to convert these centimeter readings into meters, and finally we have to find out the springs constant using this formula. K is equal to mg by L. L is the extension and mg we already calculated the load here, that was in Newton, and we would get the value of springs constant in Newton per meter. Calculated the value of springs constant using the formula. We can also plot a graph between load and extension, taking load on x-axis and extension on y-axis. It is found to be a straight line. The slope of the graph would give us the value of springs constant in Newton per meter. Thus, by calculation from the graph as well as the formula, we would get the springs constant of this given spring. Thank you.